Hi everyone, Mr. Markwick here. In today's video, we're going to be looking at residual plots again, in particular analysing essentially the pattern, if any, that they're creating about the x-axis. In my previous video, I showed you how to calculate residual values and then draw a residual plot from those values, which again, I showed you how to do that in a graphics calculator to save a little bit of time. So instead of having to work out those residual values, and certainly not drawing it by hand, the graphics calculator does all those things for you. So if you haven't already, go back and watch my previous video, Introduction to Residual Plots, where I show you how to set up your graphics calculator to calculate those residual plots, those residual values in list 3, and then draw those residual plots, and I set up mine in graph 2. And again, I'll show you how to, or how that looks in this video, but I won't show you how to set that up. You'll need to go to my previous video. Anyway, analyzing residual plots. So residual plots, the purpose really of these residual plots is, I guess, to make a further assumption to whether a linear model is appropriate for a certain data set. In this instance, case 1, we've got a scatter plot here with a least squares regression line through it. And then we use that obviously to determine the residual values, and then those values to draw this residual plot. Again, that all happens on the graphics calculator. You can see that because these points are randomly scattered about that x-axis, there's no real pattern happening here. We can then say that if there is a strong correlation, so R and R squared values are relatively strong, and our residual plot has the points randomly scattered, then a linear model is appropriate for this set of data. Okay, so we can make assumptions or predictions based on that equation or that linear model. However, if we, and this is pretty well pronounced, it won't always be this obvious, but if we do a scatter plot and our points look like this, we'll still be able to put a least squares regression line or a line of best fit. R and R squared values will still be very high. However, when we do our residual plot, we see that there is a distinct pattern happening here. Now, if there is a clear pattern or distinct pattern happening, then it tells us that a linear model is not appropriate. And in this case, something like an exponential model is more appropriate to model this set of data. Okay, so let's go and look at an example and talk about that in the context of that example. So here is a set of data. It says find the least squares regression line and state the value of R squared. So again, in my graphics calculator, in list 1, I've put all those X variables or the explanatory variables. In list 2, I've put all those Y or response variables. I'm going to draw that scatter plot that looks like that. And then to calculate the equation, the regression line and the value of R squared, press calc X, AX plus B, and here are the values that I'm interested in. So the equation of the line, so A is equal to 0.99 and B is equal to, in this case, negative 0.01. So in the form of Y equals AX plus B, the equation of that least squares regression line is Y equals 0.99x, take 0.01. Now that all looks fine. If I head in as well, I can see that the value of R squared is 0.99 and R is 0.99 as well. So the value of R squared is 0.99, which correlates to 99%, which you would think that is a perfect example of a strong linear positive correlation between the X and the Y variables here. However, this is where we then need to throw that into a residual plot and actually see, is there a pattern that suggests it might not be appropriate for linear modeling. So once I have drawn my scatter plot, it's important that you throw that line of best fit or that least squares regression line through it. So then it will calculate those values for you. For me, again, I've set up list 3 here to show those residual values. Okay, so there they are. Now, again, I've set up graph 2 so that list 3, or those residual values, are on my y-axis. Okay, so if I draw graph 2, it looks like this. This is my residual plot. Now you can see here there's a clear pattern happening with those points. Okay, so construct a residual plot for the data. There it is there. Okay, is the linear model appropriate for this data? Well, based on the R-squared value, you'd say yes, but based on the residual plot, the answer is no, because of that clear pattern. They're not randomly scattered points about that x-axis, okay? So the answer to that is no, and as I explained, because you can see a clear pattern in this residual plot, okay? So in general, as it says here in the green square, a residual plot with points randomly scattered about the x-axis indicates that a linear model is appropriate for the data. A residual plot which shows a clear pattern indicates the linear model is not appropriate for the data. So in the example I've just gone through there, example 8, the residual plot shows that clear pattern, okay, which means that a linear model is not appropriate. Okay, it's more likely that we're looking at an exponential model. And that will be the last part that we look at in this topic, and that will be my next video. The other note it says here is large residual values may also indicate that a linear model is not appropriate. Now that's a little bit harder to determine, but generally you'll be comparing two residual plots and I guess determining which one is more appropriate based on those, those larger values. Okay, so in this case alone, I can't really say that those residual values are large. I don't even have my values here on my y-axis, so it's a little bit hard to interpret that. But again, yeah, usually they'll give you another residual plot to compare this one with, and then you can sort of, I guess, compare which one has larger residual values and therefore which one is not appropriate to be modeled using that linear regression. Okay, so hopefully that helps with, I guess, understanding what residual plots are actually for and how to analyze them by looking at them. So randomly scattered is appropriate for linear modeling. There's a clear pattern. It is not appropriate for linear modeling. And in this case, or for the sake of this course, we'll be looking at exponential models as well. Anyway, thanks for watching and hope that helps.